Okay, let's kick off with the first pattern from the famous group of 23 Gang of Four design patterns. This one is called Abstract Factory Pattern, and it is a pattern you use when creating new objects. I will start with a quick summary of what we are trying to accomplish with this pattern. Remember, there's a famous anti-pattern called pattern love that applies to developers using correct design patterns in the wrong circumstances. So it's very important to realize when you're supposed to use a pattern. So, the abstract factory pattern is a good choice when you are trying to accomplish the following. You want to provide an interface for creating families of related or dependent objects without specifying their concrete classes. Your objects can be grouped into a hierarchy that encapsulates several distinct platforms, each consisting of a suite of related objects. The calling code works with abstract interfaces and classes, and does not need to know the exact types of the objects created by the factory. Okay, let's go through the points one by one. First of all, you must have the need to create two or more objects, but with a very specific relationship between them. These objects are often called products, and the pattern provides a way to create a whole set of products in one go. This set of products is called a platform. Within the platform, the products interoperate with each other in a specific way. And this brings me to the second point. To use the pattern effectively, you must have a large collection of objects that you can group into at least two platforms, with each platform containing the interoperating set of products. And finally, your calling code must only work with abstract platform interfaces and classes, and never need to know the exact type of the created objects. The factory object provides a creation service for the entire collection of platforms. Clients never create platform objects directly, but instead they always ask the factory to do that for them. The biggest benefit of the abstract factory pattern is to remove ugly if-then-else blocks from your code. Think about it. Without the benefit of having multiple platforms, you would need some kind of super platform that regulates the interaction of each possible product object with all other products. The code would quickly devolve into a mess of switch and if statements. There's an anti-pattern for this too. A single platform that tries to regulate all object interactions in an application is called a God object, and it's considered a bad practice. This design pattern makes exchanging platforms very easy, because the platform factory class appears only once in the code, in the top-level factory. So you can quickly replace the entire platform simply by instantiating a different platform factory. Because the service provided by the platform factory object is so pervasive, it is often implemented as a singleton. but we will get to the singleton pattern in a later lecture. Here is the UML diagram of the abstract factory pattern. On the left-hand side is the product hierarchy. We have a platform of two related products. The abstract versions of these products are called Abstract Product A and Abstract Product B. There are two platforms, and this gives us four distinct products. Product A1 and Product B1 in the first platform, and Product A2 and Product B2 in the second platform. On the right-hand side is the factory hierarchy. Each platform gets its own dedicated factory class. Concrete Factory 1 for the first platform and Concrete Factory 2 for the second platform. There's also a common base factory called Abstract Factory. So now the idea is that a client can simply call the Abstract Factory to create any of the A and B products. The Abstract Factory will determine which platform to use, then instantiate the correct platform factory, and then ask that factory to create the actual products. We end up with either a set of Product A1 and Product B1, or a set of Product A2 and Product B2, depending on which platform was chosen. What might surprise you is that there is no specific class for the platform itself. Sometimes you see a slightly more complex version of this pattern with an explicit platform class. In that model, the products do not interact directly. Instead, it is the platform class that interacts with the products. This is slightly more elegant because the products no longer need to reference each other, but it adds a number of extra platform classes to the pattern. In my model, I do not use platforms, and the products interact directly with each other. The platform factory is responsible for creating a set of products that are compatible with each other. This keeps the number of classes down and makes the pattern easier to understand. Now let's look at a concrete example of the design pattern. I am going to show you an application that models food chains on different continents around the world. You might have heard of the rabbit and fox cycle. This is a mathematical model that simulates rabbit and fox populations. Foxes eat rabbits and proliferate, until there aren't enough rabbits to feed the foxes. The fox population then crashes and then recovers. This leads to a kind of sine wave of rabbit and fox populations. I am going to write a program that simulates a population of carnivores and herbivores, using animals on different continents of the world. So these are the objects I'm going to need. You can see that I have two abstract products, carnivore and herbivore. I also have two platforms, Africa and Australia. The matrix contains four products: lion, zebra, dingo, and kangaroo. So I'm going to need factories to create the correct set of products. I can't have a lion being paired with a kangaroo, because these animals live on different continents and will never meet each other. So I will need a continent factory that will either create an Africa factory or an Australia factory for me. Finally, I'll add a class called ecosystem. This represents the client. I'll provide the ecosystem with a factory and then let it simulate one single iteration with one carnivore eating one herbivore. So here is the complete list of classes in this example. Okay, let's take a look at the code. So up here is the definition of the continent factory. You can see that it's nothing more than a simple abstract base class that defines the two product creation methods: create carnivore and create herbivore. Next are the two concrete factories, Africa factory and Australia factory. You can see that both classes derive from continent factory and implement the product creation methods. The Africa factory creates lions and zebras, and the Australia factory creates kangaroos and dingoes. Next are the product classes. We start with an abstract herbivore class, which right now has no implementation. But the carnivore class has a single method called eat, which expects a herbivore argument. So, carnivores can eat a herbivore. Next are the concrete product classes for lion, zebra, kangaroo, and dingo. And down here is the ecosystem. The constructor expects a single argument of type continent factory and then uses that factory to set up a single carnivore and herbivore. And down here is a run method which kind of runs the ecosystem by having the carnivore eat the herbivore. Finally, in the main program method, I set up an entire ecosystem with the Africa factory and run it. Next, I do the whole thing all over again, but now with an Australia factory. In both cases, the ecosystem will consist of a single carnivore and herbivore from that continent, and the carnivore will eat the herbivore. Now notice that the ecosystem class has no idea what kinds of objects are being created. It has no clue what a zebra or a lion is. All it cares about is creating a single carnivore and herbivore, and then have the one eat the other. Let me run the program to prove that everything is working. I'm compiling the code now, and now I'm running it. And there you have it. The lion eats the zebra, and the dingo eats the kangaroo. Here's a quick checklist you can use to implement the abstract factory pattern. Make sure you have a large product family with lots of annoying interdependencies between products, and your product handling code contains lots of switch and if statements. Then create a matrix of platform versus products and check if each product can be neatly grouped into a platform. Then make sure you have at least 2 abstract products and platforms. Create an abstract factory class with abstract create methods for each product type. Create a derived factory for each platform and implement the create methods. And finally, make sure the client does not use new anywhere and only uses the abstract types. And here are some final comments. What I've shown you so far is an abstract factory design pattern that uses factories to create the product instances. But there's no rule that states that you must use factories. You can also use a builder or prototype pattern to create the actual objects. Pick the creation pattern that best suits your needs. The abstract factory in my code is a regular object. But because it gets called so many times from all over the place in your code, you often see it being implemented as a singleton. This is perfectly fine. Feel free to use the singleton pattern here. But do keep in mind that many developers consider the singleton pattern to be harmful and try to avoid it as much as possible. You might get into an argument with your colleagues on this one. And finally, you've seen that the abstract factory pattern effectively hides the concrete types of the product objects. This type of information hiding can be useful if you want to hide certain classes from the outside world. The pattern of choice for this kind of information hiding is called facade. We'll get to that shortly. But you could also use an abstract factory instead of a facade. Something to consider. Okay, so here's a summary of what we've learned. The abstract factory design pattern provides an interface for creating families of related objects without having to specify their concrete classes. Use this pattern if your objects can be grouped into a hierarchy that encapsulates several distinct platforms, each consisting of a suite of related objects. The calling code only uses abstract classes and never instantiates objects directly, and it does not need to know the exact types of the products being created by the factory. You can combine an abstract factory pattern with a builder or prototype pattern, or you can implement the abstract factory as a singleton. The abstract factory design pattern can sometimes be used in place of the facade pattern.